Okay, in this particular video, we're going to clear up maybe some of your confusion on those last couple of slides that you looked at. We're going to talk about what domain is, what are domain restrictions, and then in the end of this, we're going to talk about how to find domain restrictions, okay? So I'm going to give you the definition that we'll use just for right now for both of these. This is not going to be the hardcore definition for domain. We're going to be talking about domain a lot in this unit. It'll come up multiple times. But just for right now, this is the way I want you to think about domain, okay? So domain is going to be all the values that you're allowed to plug in to a function, okay? So values that are allowed. And we're going to talk about what it means for something to be allowed or not allowed, okay? Domain restrictions then just means values that are basically not allowed. They cannot be plugged into a function for some reason. Okay, we'll talk about that in a second. So the first thing we'll start with is actually the function that we looked at in the last video, which is f of x equals x plus 4. Okay, so we're going to run some tests right now. We're going to test out some values, some numbers, and plug them in and see if they work or not, if they're allowed. Okay. So the first thing I'm going to do is I'm going to check with a couple of positive numbers, okay? So we can just easily kind of think about this one because we're just doing that number plus 4. But maybe let's think of the number 3. So if I were to plug in 3 for x, okay, I would get an output of 7, right? And I could check with a couple other positive numbers, and it looks like every time I plug in a positive number, there's no issues with the output. The output is totally fine. There's no problems. Our function is working like it's supposed to. All right? Perfect. So for this function, all positive numbers end up working out. Then the next test you're going to run is negative numbers. Okay? So let's think of, how about negative 4? What if I plugged in negative 4? Well, negative 4 plus positive 4 makes 0, right? Is that an issue? Can I have an output of 0? Yeah, that's totally fine. I can definitely have an output of 0. There's no problems with that. And any other negative number I plugged in wouldn't have any issues either with the outputs, okay? So this one, negative numbers will work totally fine as well. And then the very last test you're going to run is 0. Can you plug in 0? So I plug in 0 right now, and I get an output of positive 4, right? No issues there. That's totally fine. 0 works out great. Okay. All right. So if it passes all 3 of those tests, then what you get to say is there are no restrictions. There were no problems. This function passed with flying colors. There were no restrictions on the domain, on the values that I'm allowed to plug in. Okay. I can plug in anything that I want to. And a more mathematical way to say this, that I can plug in anything that I want to, is to say I can plug in all real numbers. I would say my domain for this function is all real numbers. Also, a really nice shorthand way to write this, if you don't want to end up writing out this whole entire thing, mathematicians use this symbol to represent this phrase, all real numbers, with this fancy looking R right here, okay? So this symbolizes this phrase, all real numbers. Great. So next thing I want to talk about is some of the notation that you saw with function operations, so addition, subtraction, multiplication, and division, okay? So this notation might look a little confusing at first, but to clarify it, this is just saying if I take one function, like maybe this function f over here, and I add that together with function g, another way to write this notation, another way to symbolize 2 functions being added, is I can also write it like this, okay? So I could take the names, because remember f and g, those are the names. Those are the names of the functions. I can take the names and I can put a plus symbol between them, put those in parentheses, and then put another set of parentheses to show that it's a function. I can plug something in, there's an input to this. Want to be really clear here, this is not multiplication, okay? This notation, the way that this is symbolized, does not mean that there's multiplication happening here, okay? Just like here, where I have an f and it's right next to this x inside parentheses, this is not it does not mean that there's multiplication happening here. This is just the name of the function, and this is just showing me that I can plug something into this function, okay? So just be really clear, that's what that notation means when you're looking at that in the slides, okay? So for each of these operations, I'm going to tell you right now that for addition, anytime we're doing an addition problem, a subtraction problem, or a multiplication problem, the domain is actually going to be all real numbers. I can plug in any positive, negative number, or 0, and it'll work just fine. Okay, so all real numbers. So that again means that there's no restrictions. There's no restrictions on the domain. And let's go ahead and just kind of like copy that and paste it. Oh no. That is okay. Clone this. Boom. So for every single one of these operations, it's going to be all real numbers. There's no restrictions on the domain, okay? However, there's going to be a little asterisk here. However, there are some types of mathematical operations that we're going to have problems with that we will actually look at in future units. And the slides talked about them a little bit. We're not going to have to worry about them for this first assignment, not until we get a little bit deeper into this unit, okay? So some of the stuff that the slides showed, right, were radicals or square roots, okay? Do not worry about those. We'll talk about those later, but that would be something that we would not have all real numbers for square roots. So if you see that pop up, you're going to have a different domain rather than all real numbers, okay? Or if you see logarithmic functions, okay? So both of those we'll talk about more in their own separate units, and this one we'll get to a little bit later in this unit. So for now, don't worry about those, okay? The only one I really want you to worry about right now is division, okay? Because this one is not going to have a domain of all real numbers, okay? So let's consider the example over to the right-hand side. So this one says find f divided by g of x. So all that means is that we're going to take our function f, which is just 4, and write that over our function g, which is x minus 3. Done. So I found f divided by g. Don't have to do any simplifying. That's as simplified as it can get. However, if I wanted to figure out the domain, so what values am I allowed to plug in, let's think about a scenario for one moment. So let's think about the fraction 1 divided by 4. So let me paint a picture with this fraction right now. This fraction I could think of as having 4 pi's, okay? There's 4 pi's here. And this fraction could symbolize that I ate 1 out of the 4 pi's, okay? Now let's think about another fraction, 0 divided by 4. So using the same analogy, I have 4 pi's, okay? What does this mean? Okay, well this would mean that I didn't eat any of the pi's. I ate 0 out of the 4, okay? I didn't eat any of them. So still using this analogy, what do you think it then means to have 4 divided by 0? Okay, well this would then mean that I have 0 pieces of pie, but I ate 4 pieces of pie. And that doesn't make any sense, right? So whenever we have something like this happen in math, where we have a fraction and there's 0 in the denominator, this doesn't make any sense logically, okay? So in math, when this happens, when we divide by 0, we get a divide by 0 error. We're going to call this undefined. What undefined means is that mathematicians, as of right now, don't have a definition for when something is divided by 0. They're actually currently trying to figure that out. They're trying to figure out what this means logically when something is divided by 0. But as of right now, this it is kind of a bunch of nonsense when we think about it, okay? So we get an error, okay? So if you ever have this happen, where you have a denominator, it's equal to 0, we would call that undefined. So therefore, when we're running our 3 different tests on this function, okay, once we've taken f and divided that by g and we've gotten this result, you can see maybe right away that there's a positive number that I plug in and it causes an error to happen, okay, right? Like if I plugged in the number positive 3, that would make the denominator turn to 0, okay? So what I'm going to say is that I actually have a restriction on the domain. I'm not allowed to go ahead and plug in any number that I want to, so it's not all real numbers. There is one restriction. I would say that the restriction is that I'm not allowed to plug in positive 3, okay? I can plug in anything else, but positive 3 is off the list. It is a restriction. So the last thing that we'll do is talk about how to find those restrictions. If we're dealing with a little bit of a harder looking denominator, maybe you can see what that number is right away that you're not supposed to plug in. But if you're ever concerned on how to find it, this is how you would do it, okay? So to find the number or the restriction that you are not allowed to plug in, what you would do is we just have to think we don't want this to be 0, right? We don't want 0 in the denominator. So 2x plus 5 cannot at any point cannot equal 0. Hey, this is actually now an equation that we can go ahead and solve, and it'll actually tell us the number that would make the denominator 0 that we don't want to have. So let's go ahead and start solving this for x. So if we subtract 5 from both sides, then we get 2x cannot equal negative 5. And then if we divide both sides by 2, we get x cannot equal negative 5 halves. Okay, and that's it. That's the magic number. That is our restriction. Okay, we cannot plug in this number. Okay, and I encourage you to test this out right now. So try to take negative 5 halves and plug this in, and you would see that the denominator turns to 0, okay, which we would call undefined, okay? So that's the big word from this intent. You might have to use that for the homework, undefined. So that was basically the review of what domain is, what domain restrictions are. Only really have to worry about domain restrictions as of right now when we're doing division. And the way that we would write this for division is the denominator, or in this case they're using g of x, the denominator is not allowed to equal 0. So denominator cannot be 0.